Epistasis is when the expression of an allele at one loci is either masked or changed based on the expression of another. This can result in genotypes that are different from each other that express the same phenotype. For single dominant epistasis, it's the dominant allele at one loci that masks or changes the second loci, meaning that if a genotype contains a big A allele, then it's always going to represent one particular phenotype, no matter what the other loci is. In this video, I'm going to be using a hypothetical situation, which I'll call the train scenario, to better explain how this pathway works. In this pathway, I'll be using 3 different types of flowers: the white precursor, the yellow intermediate, and the purple end product. My 2 loci are the A alleles and the B alleles, with the dominant A allele being the one that masks the expression of the B alleles. In this case, we would say the dominant A allele is epistatic to the B alleles. For the train scenario, let's say you're a florist on a train that needs to deliver flower seeds to each flower shop. You're given a bag of seeds, but you don't know which seed belongs to which flower. All you're given is the genotype of the seeds and know that it's single dominant epistasis. This is our F1 generation cross, and this is one of the seeds from that cross. Let's see what flower this seed belongs to. So our seed has a big A, and we know to be a white flower you must have a big A allele. And since the big A is the dominant allele that masks the other loci, it doesn't matter what the other allele is. Having a big A is going to make this seed a white flower. Let's try this next seed. This seed has 2 little A alleles, so it can't be white, but it has the potential to be yellow. And it doesn't have a big B allele, it has 2 little b's, meaning that it can't be purple, so it must be yellow. Finally, here's one more seed from this cross. Again, this one has 2 little a's, so it can't be white, but it could possibly be yellow. But this time it has a big B allele instead of a little b, so it can't be yellow, it must be purple. We had a total of 16 seeds from this cross, and if we went through all of them, 12 seeds would be white, 3 would be purple, and 1 would be yellow. Let's go through the same thing, but with a different cross. And here's one of those seeds from that cross. Let's try to figure out what flower this belongs to. So this seed has a big A allele, which we know represent white flowers. But notice how it also has a big B allele, which is representative of purple flowers. Again, even though it has a genotype to be purple, that phenotype is always going to be masked by the big A allele, making this seed a white flower. If we continue with all the seeds from this cross, 8 would be white flowers and 8 would be purple flowers. This is because 8 seeds have the big A allele, and the other 8 have 2 little A alleles and at least 1 big B allele. These are my sources, and thank you for watching.